corrected 1-2 and 1-3. Before that, I have my list up here. I do have my list. The 5 things I asked you to do last time. Remember the 5 items on my list? Michaela wasn't here. Did you get them though? My list of 5 things? Does anyone have a question about any of those 5 items I asked you to do? Anyone want to admit they haven't done all 5?
I'll admit it.
Okay, which of the 5 have you not done?
I just didn't correct all of the ones in here.
Okay,
I did like,
okay, that's a minor, so she hasn't done all of her corrections yet. It's a lot. So she's not done with that, but you're probably up to date for at least today. That's good. What are some other ones you haven't done? Yes?
I didn't get the book.
You didn't get the book yet?
Today and they were out. So
You're in luck. I knew that would happen. A couple people haven't bought the module packet yet, so you haven't corrected it yet either. There's 2 of them on the list, right? Any other issues accessing the My Stat Lab? Are we able to do that? Yes?
I wasn't.
Oh, that's because you have to actually get,
I did add it, but
Uh-huh.
it still wouldn't let me.
it takes about 3 hours for it to show up on Canvas, so that might have just been the issue. Anybody who added the class will have a little bit of issue getting into it through Canvas for around 3 hours, what they're telling me. I don't know, it might be different. Yes?
I'm enrolled in class and it wouldn't let me access it.
Which is the it that wouldn't let you? Like,
From the same problem.
when you showed up on Canvas, it didn't show up there?
Yeah, I had a problem.
Let's look at it at the break, because it should show up there for you, yes. You couldn't, didn't know how to access the textbook? Sometimes that's a browser error. We'll maybe check that during the break too. I have a paper that tells you how to get to the textbook.
I
Yes?
added the class and within seconds it showed up on Canvas.
Seconds, less than 3 hours.
Yeah, it was on there.
Oh, so the rest of you, I don't know, just do what she did, right? Hopefully we'll figure it out. So it sounds like there's a handful of you that had some issues accessing, but maybe we'll do that in the break and figure out what it looks like. Yes?
Since I added the class too, I had the same problem where it wouldn't pop up and I couldn't do my homework for it. It's
Uh-huh.
not due till next week, right?
It's nothing's due until Monday, which is why I made it not due until Monday for these little issues right here. So if it's still not showing up, there's an issue. If you've added the course through Insight/WebAdvisor, if you've added the course, they're telling me it should show up on Canvas within 3 hours, or a few seconds if you're lucky. And once it's there, you just need to click on it and it will redirect you into My Stat Lab. So for those of you who are having issues, we'll try to look at it during the break or after class in the Math Lab if we need to. Other questions about my list of 5 things? Okay, for those of you who were not able to purchase the packet of notes, I knew that would happen. I did bring a few extras for the people that don't have them yet. So please raise your hand if you do not have them yet. Hope it's not too many, so by Monday you'll have all 5 of these completed. Actually, you'll have even more than those 5 because you have other homework assignments to do by Monday. No questions about the list of 5 things. I really hope the questions are because you're on top of it and not because you're so lost you don't know what to ask. Anybody in that boat? No one's willing to admit it. Okay. All right, so we're going to jump in. We're starting with section 1.2, the new section 1.2, right? Page 8. Page 8, 1.2. So last time we talked about how there might be bias and so forth when you're trying to collect a sample of data. Now we're going to talk about some terminology in terms of what kind of data we actually collect. Everything is data, even if it's not numbers. I could ask you what your favorite movie is, and that would be data. I'd be having all these different lists of movies and so forth, that would be data. And I might be interested in what the favorite movie is of all college students, not just you guys. And so that would be a different group. So we have like labels and terminology to talk about everything here. So we're jumping up at the top of page 8 there. Types of data. The first 2 lines are about parameter and statistic. They are both numbers or values that measure something. Maybe you want an average. We call it a mean in statistics, but maybe we want an average. Thank you. The average age in this room is different than the average age of all college students. They're both averages and they're both average ages, but the difference is you are a sample, you are a smaller group out of a bigger population. So when it talks here about a parameter, a numerical measurement describing a population, that's a number that would describe the large group. if I could actually get the average age for all college students ever. That's a lot of college students. But if I could go and get all those ages, that would be a parameter because it represents the large group. Notice parameter starts with a P, population starts with a P. Helpful to remember which one goes with which. And then a statistic describes a sample. A sample is a small group out of the bigger group. So if I happen to choose you guys as my sample, and I got your average age, that would be a statistic. The whole reason we learn statistics and all this terminology is that in real life, most of the time it's too time consuming to get the entire population and measure it. I mean, if I really wanted the average age of everybody, think I'm really gonna go get all those ages? But I will take the statistic and use that to approximate what it is for the large group. So you'll be asked, is this number a statistic or a parameter? Statistic means it represents a sample, they both start with S, and parameter for population. Are we okay about sample versus population? Population's the big group, sample's the small group. And then once we start collecting data, there's all types of data. Quantitative data, numerical, counts or measurements. What type of question might I ask you all that would be a quantitative variable?
Your age.
Age, I could ask you all your age, that's quantitative, you will tell me a number. That's quantitative data. What else could I ask?
Height.
Your height, that's quantitative. You're gonna give me a number when I ask you your height. Anything else? I heard somebody quietly, was it phone number? Phone number? Yeah, that's a number, quantitative. We wouldn't necessarily want to find the average phone number, but we could get numbers from each of you, right? The average phone number would be a little strange, we're gonna actually talk about that in a little bit. But the phone number is quantitative. And we could list all day long. How many pets do you have? How many miles is it to your dad's work? Whatever. I mean, we could just all day long we could talk about quantitative data. Categorical data is data that's a name or a label. It's pretty much when your answer is a word, not a number, right? If I asked you your favorite movie, you all might give me different movies, but some of you might have the same one. Those are categories. How many people like The Terminator? How many people like Wizard of Oz? So like, we could count how many are in each category, but each of you would give me some words as opposed to giving me a number as an answer. A lot of people think that those are still quantitative because I might list, if I ask you, raise your hand if you like to drink coffee. And I can tell you that there's 42 people who like to drink coffee. That's a number, but that's really a yes or no question. Your answer, your individual answer would either be yes or no. Yes, I like coffee. No, I don't. See the difference there? You be careful. Just because you see numbers doesn't make it quantitative. It's whether or not the individual answers are numbers or categories.
It's the answer.
Say that again?
It's the answer that.
Yes, it's the answer that matters, right? I once had some students who did a project who told me that the average, so they asked everyone what their favorite flavor of ice cream was. So, there's chocolate, strawberry, Neapolitan, I don't remember what else they had, Rocky Road. And they told me that the average flavor of ice cream was 3.6. And I'm glad that people are laughing, which tells me we have a little bit of idea that that's wrong. But what they did is they took all the numbers in the categories. Maybe there were 6 people that said chocolate and 5 people that said strawberry, and they took those numbers and averaged them. But does it make sense that the average ice cream flavor is 3.6? Because those weren't actual quantitative numbers that made any sense. It was really categorical. So it would have been better if they said more people liked chocolate than strawberry or something like that. So categorical is anything that is a name or a label. Okay, on the difference there? Okay. Then when we talk about quantitative data, numbers, remember, quantitative, think of quantities. Quantity. There's 2 ways to talk about it. There's discrete and continuous. Discrete means something that's countable. So if I asked you, how many of these pens do I have in my bag today? We go in there and we count, and I probably have 4. Maybe I have 5, sometimes I pick up an extra one, or maybe I have 3 because I lose one. I try to have 1 of each color. But I couldn't have 7.5. Okay, maybe I broke one, but I wouldn't have it in my bag if I did. But when I count how many pens I have, it has to be a whole number, right? It doesn't make sense to talk about 7.5 pens. So that's what we mean by discrete, a countable number. It has to be a whole number. It has to be something you're counting. You can't have 7.5 pens. Well, maybe you could, but I don't, typically we don't. Right? Or if I asked you how many, I have my Fitbit on, how many steps have I taken today? They're not gonna give me a half a step. They're picking it up with their regular steps. Everyone okay with being countable? Has to be a whole number. Now, continuous, there's infinitely possible answers. So let's say I asked you how tall you were in inches. 5 feet, by the way, is 60 inches. So from there, if I asked you how tall you were in inches, anyone want to volunteer their height in inches? She's 64 inches tall? And she's 5'4". Okay. Anybody else? No, how long? I don't care if you're wrong. Yes.
I am actually 5 feet, so.
So she's 60 inches exactly? Anybody else? 69 inches?
65?
65? I claim I'm 65 and a half. Does that make sense?
Yeah.
No.
That means I'm 5'5" and a half, right? I could be half an inch. You can measure half an inch. Half a pen didn't make sense when I'm counting them, but half an inch is okay. There are some measurements that can be decimals or fractions. That's what we mean by continuous. If I had a really precise ruler, maybe I'm really 65.369 inches tall, if I really had a really precise way to measure. If you can have a decimal or a fraction, that makes it continuous. Even if the answer is a whole number, if it could have been a fraction or a decimal, that makes it continuous. So there might be a problem where they say, here's a person's salary, they earn $12 an hour. Is that discrete or continuous? So you might say, hey, 12's a whole number. That's gotta be discrete. She said whole numbers are discrete. But the question really is, could that 12, could it have been a fraction or a decimal? And would it have made sense? So you could make $12.50 an hour, right? 12.5, or maybe you make $12.32. You could have decimals, that makes it continuous. So discrete data is the ones where the number has to be a whole number. Continuous is where it could be a decimal or a fraction, it doesn't necessarily have to be though. Do you understand that subtle difference? So all of you, when I asked you, gave me whole numbers for your heights. But some of you could have given me fractions like I did with mine. Still okay up to there? So there's a lot of categories here. Categorical, right? Is it a quantitative or is it categorical? Is it discrete or is it continuous? You really want to make sure you understand the terminology and ask questions if you don't understand the subtle differences, because that's the big thing here, is a lot of these things are really close, but subtly different. All right, so now in the middle of the page 8 there's levels of measurement when you're getting some data. You'll be asked a lot of questions on your homework about which level is this. And I'm going to go through in order that I have them on this page. Nominal is data that the name, a label, or a category, and you couldn't put them in order. For example, the ice cream one I was talking about. If I asked you all your favorite flavor of ice cream, you're all going to give me a name for your favorite flavor, but I wouldn't know which way to order them in. Like, does chocolate come before strawberry? After I counted, maybe I could order them, right? But there's no order to those. Categories of anything. If I asked you your student ID number, that's a number, but what is your student ID really, what is it really?
A list of numbers.
It's a list of numbers, and what does it represent?
You as a student.
It just represents you as a student. It's kind of the same thing as your name, really, right? Your student ID number is really your name, like your social security number is like your name. It wouldn't make sense to average your social security numbers. Say, hey, the average in my class is this number. I mean, it doesn't make sense because you're really talking about names. So nominal are categories that seem obvious, but sometimes they're numbers that we use as names. The phone number that, who came up with that? Celia, right? Was that you that said phone number earlier? Phone numbers are really names too. This is the number in my phone that goes with this person's name, right? So that would be another example of nominal. So that's any kind of answer that's a category or really is used as a label or a category. That's nominal. Ordinal is next. That's where you actually have an order, but you don't know the difference between the categories. For example, let's say I asked you to rank these drinks. I'm putting 3 drinks up here. Coffee, water, and milk. I don't know who drinks milk anymore. I do. I love milk. And I asked you to rank them in order of your favorites, 1, 2, and 3. Who wants to volunteer their answers? What do you got? What's your favorite?
Water,
This is your number 1?
yeah,
Uh-huh.
then milk,
Then milk,
and coffee.
then coffee. This is her order. Yours might be different, that's okay. So she has these in order. But does she like coffee, like water 3 times as much as coffee? Like, or does she like water and milk almost the same, but coffee's a far distant third? You know what I'm asking here? It's like we don't know what the difference is. I probably would agree with her if it was my list as well. And I would say, yes, water's my number 1 for sure. And milk is pretty close to here. But coffee's probably on the bottom corner of that board over there if I listed all the other drinks in the world. I don't drink coffee. I can't stand coffee. Bring tea every day. And so coffee is a very, very distant third for me. You know it's my third and her third, but we don't know the differences. So that's what it means when it says the differences are meaningless. You can put them in order, but you can't really compare one to the other and know how much better or worse it is. We do this when you go on and you rank. They rank movies and give them stars, from 1 to 5 stars. A 5-star movie versus a 1-star movie, does that mean it's 5 times better? I mean, or how much better is a 4-star versus, you know it's better, but you don't really know the differences. So all you can do is put them in order, but not really explain the differences. That's ordinal. All right there? Ordinal. You can put them in order, but not make any sense of the differences. Then the next step up, so each of these is a step up. It's kind of the last one with a little bit more detail thrown in. The next one is interval, which is a little bit hard to understand. It says you can arrange it in order, and differences are meaningful, but there is no natural zero or starting point. So I'll give you one of my easiest examples of interval. That would be the temperature. So I don't know, the temperature this morning was not scorching yet. So here's my beautiful picture of a thermometer. What was the temperature this morning? Maybe 70? 68. 68? Well, put 70. 68, around, it's probably 70 by now, probably past it already, right? So 70 is the temperature, and maybe somewhere else this morning it's 30. Not here, but somewhere it's probably 30, somewhere in the world, right? I'm talking about Fahrenheit degrees. It could even be 0 somewhere, especially when we get into the later part of the fall and the winter. And it could be -10 at some point, right? All this makes sense when we talk about temperatures. So we can actually talk about the differences between this. It's 40 degrees warmer. We know what 1 degree is. I mean, we can't necessarily feel it, but we know how to measure 1 degree warmer. There's a difference between, like you said, 68 and I said 70. There's 2 degrees difference, so the differences make sense. So that's what it means here when it says you can put them in order, like smallest to biggest, and the differences are meaningful now. But there is no natural zero or starting point. There is a 0, but when we say a natural 0, 0 means nothing. If I asked you how much money you have and you told me you have 0, that means you have no money, right? And if I ask you how much of your homework have you done and you say 0, that means you haven't started your homework yet. But if I ask you what the temperature is and we say 0, that doesn't mean we go outside and feel nothing. All right? You still feel something. Actually, it feels pretty cold if you go outside, especially dressed like this. So it doesn't mean the absence of something, right? And when you're talking about temperatures, it's just kind of a number on a scale that means something. It doesn't mean you have nothing. You have no temperature. And you wouldn't say that, this is more than twice as hot as this. We don't talk about temperatures like it's twice as hot yesterday. Like, temperatures don't work that way, right? Because we don't have a zero, that means no temperature. Everyone all right with what this example has to do about what it means differences are meaningful and no natural zero? The only examples I can come up with, I had a student last semester who gave me a third one, I don't remember what it was. The only ones I can ever come up with, until I learned a new one that I've already forgotten, are temperatures and years. Like you were born in the year 1995. The year zero, we're not gonna get into religion. The year zero was not when everything started counting, right? That's not when time began. I think most of us would probably agree with that, yes.
What about women's jeans? You have a size 0, but that doesn't mean there's nothing.
Oh, there's a new example. Sizes for jeans. There's 2, 4, 6, and they have a 0 for people who are skinnier than skinny. 0 doesn't mean you don't exist and you don't wear jeans. I love it when I get new examples. You can put them in order, right? Size 2 is bigger than a size 0, but 0 doesn't mean you don't even exist. You still get to wear those jeans. Love it when people give me new ideas. So now, the only examples I can come up with today, because I can't remember my other one, are temperatures, years, and women's jeans. There might be other ones. I dare you to come up with them. I always want new ones. I should have written down my one from last semester. We all right though how that means, what I mean by no zero, but the order does make sense? Yeah, there is a 0, but not what we call it. A natural 0 means nothing, right? Invisible genes when they're size 0. That would not be recommended. All right, so that's interval. And then ratio is everything else you've ever seen. Money is a perfect example. If you have 0 money, you know you have no money. And if you have $10 and she has $20, she has twice as much money as you. Right, 10 versus 20. The word ratio is you can talk about twice as much, half as much, and that makes sense. Where here I couldn't talk about something being twice as hot or half as hot with these numbers, right? But money's a good example. Height is an example, right? If you measure something at 0, it has no height whatsoever. 0 is and even a negative wouldn't make sense in that case, right? You can't have a negative height. So 0 is the beginning of where you start measuring. You could have negative money. This means you owe money instead of you get money, right? But ratio is pretty much everything else you've ever seen. And 0 means you don't have it, whatever the it might be. Questions about page 8? A lot of vocabulary today. Table 1.2 in the textbook summarizes these 4 levels of measurement. Right before the break, I'm going to give you a handout that tells you how to read our textbook online, for those of you who haven't been able to access it yet. She had some trouble getting there. We're going to find out why. But if you want to go back and read some more examples of those, it's in our book on table 1.2. How are we feeling? So far, so good? No questions? Okay, let's flip over and talk a little bit on page 9. So now we've talked about being careful not to create bias. That was last time. Now we just talked about all the different types of data we could collect. We'll be talking fairly soon about your project. I told you there'll be a project this semester, and you're going to go out and collect data, and maybe you're going to get some categorical and some quantitative data. So you might be asking people their favorite movies and their heights, or how much money they make, whatever it might be. How you collect the data, you have some options. One of them is that you could just go out and do what we call an observational study. Here on the top of the page. You just go and you observe whatever it is you're looking for. Every semester I have someone who chooses to do their project on cars. And I once had a student who went out here and stood on the corner and just counted. This is how many blue cars went by, this is how many white cars went by, this is how many trucks, this is how many SUVs. I don't know if it was the most interesting project she came up with, but that's what she wanted to do. The point is, she was observing. She just stood and observed whatever her sample was going to be. So her sample was the cars that happened to drive by that morning between 9 a.m. and 10 a.m., whenever it might have been. So she was doing an observational study, just watching, looking, and recording what she saw. She wasn't interfering with the car. She wasn't, jumping out in the road. Hey, stop! Let me ask you a question about your car, right? Let me tell you something and then get some information. So observational study is just observing. Whether you're actually observing with your eyes, or you're looking up some data online, or you're handing out surveys and getting information back, you're just observing. You're not interfering with it in any way. The other way is an experiment. Typically this happens all the time in science. Some of you have had science classes before, where some treatment, they call it treatment, is applied to the subjects. The person or group does something to affect the outcome. So let's say I think I've got this new drug that's going to help cure cancer. I really wish I did. I'm going to take this drug and this, what we call a placebo, something that really does nothing, but you can't tell the difference when you look at them. And I'll administer one drug to some people and the placebo to others and see if there's any difference in the results. So I've now deliberately affected my results by putting people into one group versus the other group. So I've applied some treatment now. So now I'm not just observing, I'm doing an experiment. I had a group once who did their project on dogs. And they wanted to know, one of the girls worked at a vet's office, and they wanted to know how they spoke. It was actually next group. How they spoke to the dogs, if it affected how the dog reacted to them. So if they came in and were kind of rough to the dog and spoke kind of harshly, how would the dog react to them versus if they were very sweet and kind and gentle with the dog. So, and it was like every other dog, they would go through and speak to it differently to see how the dog reacted to them. So that again was an experiment because they were doing something to affect the outcome, as opposed to just checking to see how each dog acted when it came in. That would have been different. Clear the difference there? Depending on what you're trying to find out, you might do one versus the other. Okay, these next two things on the list here, simple random sample and random sample, take 2 minutes to read them, and then I'm going to discuss them. And these are two of the hardest things for anyone to wrap their brain around. So read them first, I'll shut up, and then we'll talk about them. Reactions? Who thinks they could explain the difference between those two things? Ooh, silence, Stephanie. You think you could?
Maybe.
Ooh, I like a maybe. Is there anyone who thinks they sound pretty much the same? Is that your hand up?
Yeah.
They sound kind of the same, don't they?
They're almost.
They're almost the same. And this is why this is one of the hardest things for stat students to get. I work in the lab so many hours every semester, and even if it's not my students, this is the most common question I get in the math lab. It's, Jill, I don't know if this is a simple random sample or a random sample, and I still don't think I know the difference. And I spend all day for the first couple weeks telling people what the difference is between those two groups. Is your hand up?
Isn't simple just like out of a sample instead of a population?
Both of them are samples. So both of them are you're collecting a sample out of your population. So let's say we have all LMC students and we want to collect a sample of some LMC students. So then the question is, once you get that smaller group, is it a simple random sample or just a random sample? We're going to talk through it, don't worry. I'm going to use an even smaller population from our discussion today. So let's assume that you guys are my population and I want to select 4 of you. That'll be my sample of size 4. Okay? So we want to discuss what it means to be a simple random sample versus a random sample. We're going to talk about simple random sample first. If I take all your names, I put them all into a bowl and I mix them all up here, I got my big giant bowl here, and I reach in and I pull out 4 names. Let's talk about that. It says here, a sample of n subjects, I chose 4. N was my 4, right? My 4. We're going to have a sample of 4 subjects that's selected, so every possible sample of the same size, 4, has the same chance of being chosen. So I'm gonna reach in here and pull out 4 names. Is it possible that I'll happen to get these 4 people who happen to be sitting in the front of these rows right here? Could I get all 4 of these? I could. Am I just as likely to get the 4 people that are sitting in the back over there? Same chance, right? Or maybe I'll get 1 from over here and 2 sitting next to each other in the middle and 1 over there. There's no group that's more likely to happen than others. We agree? If I just put them all in a bowl and pull them out? That's the best way to think of a simple random sample, is imagine if you put everybody's names or numbers into a bowl and you pulled them out. Is that what you're doing? A lot of times the description may not say that's what, we'll put it into a bowl, but the description is very similar to comparing it to that. That's what makes it a simple random sample. Every possible group has the same chance of being selected. Those are my words to go along with the specific definition. So what about random sample? How's that different?
Because it's individual, like the last one we were talking about a group, and this one says individual member from the population.
Right, so each individual has the same chance. Okay, so let's talk about that. In my example of the bowl, do you all have the same chance of being chosen out of my bowl?
Yeah.
Yes. See how they sound the same? So the simple random sample that we just discussed is a random sample. Random is a little bit looser. It's a very specific one. If I pull names out of a bowl, you all individually have the same chance of being selected. But also every possible group could come out of my bowl. So it was a random sample, and in more particular, if I use my bowl, it's a simple random sample. I'll give you an example of something that's random but not simple random to help you see the difference. Imagine for the moment that every row has 4 people in it. There's 10 rows here, say, 4 people each. I'm going to use my little random number generator on my calculator, and I'm going to pick a number, and my sample's going to be everybody in that row. Do you all have the same chance of being selected? If there's 4 in each, pretend there's 4 in each, otherwise it doesn't work. If there's 4 in each row and I pick a number between 1 and 10, is there anybody here who's more likely to be chosen than somebody else? No, right? Because I'm just as likely to get this row of 4 than I am to get that row of 4. You're not sitting over here going, oh great, my chances just went down. Every individual person has the same chance. But will I ever get a group with these 4 people in it? Not doing that technique, right? Because I'm taking a whole row. Either I get this row or I get this row. These best friends forever are never going to be in the same group. So it's random because every individual has the same chance, but not every group could happen. That's why it's not a simple random sample. I need someone to ask me a question now. If you don't ask me now, you're going to be asking when you start doing your homework. Because everybody in the lab asked me this question. Yes?
So just to be clear, the simple random sample is more about a group, a selection of a group size, and then the random sample is individual chances of being selected.
You're correct, except that the simple random is also random. So in a simple random sample, every individual has the same chance, and every group has the same chance. So you're right, it is more about the group, but it's not ignoring that first part. Random just means every individual, and simple random means every individual and every possible group. Does that help? Mm-hmm. Other comments or questions? I see some of your heads spinning like, I still don't get it. We'll beat it up till we're sure we're kind of getting it. If I gave you a list of a whole bunch of scenarios and asked you which ones were random and which ones were simple random, do you think you'd be able to tell the difference? Yes.
So simple random sample has to have 2 criteria.
Yes, I like the way he says that. 2 criteria for simple random. Every individual has to have the same chance, and every group has to have the same chance. That's what makes it simple random sample. And the best way to recognize it is, can you compare it to putting everybody into a hat and picking some out? Because once you mix them all in there, every possible group could come out. Once you do something to lump people together, like I put you in rows, all of a sudden you've restricted the groups. And that's how you can tell it wouldn't be simple random anymore. Yes?
So like a random sample is like getting a bunch of like sandwiches and like putting in a bag, taking a random sandwich, or like a simple random sample is like every ingredient in a bag.
Say it again for me, please.
It's like, so a random sample would be like putting sandwiches in a bag and picking one out, while a simple random would be like ingredients in a bag. Take a sandwich.
Okay, I like what you're saying, but we have to clarify it a little bit. So he's saying if you already make sandwiches and put them in a bag versus if you put the ingredients in the bag. So let's say, but your sandwiches all have to all be different. That's the thing. That's what. So let's say you have one sandwich that's on sourdough and it's peanut butter and jelly. And then you have another sandwich, I'm making these up. Then you have another sandwich that's on wheat bread and it's got ham and cheddar. And then you have another sandwich, I don't know, it's on something else. So then if you randomly pick it, you can't get sourdough with the ham and cheddar because it wasn't made that way, right? So that would not be a simple random. But if we had just thrown the ingredients in and reached in there, you could get the sourdough with the ham and cheddar because they weren't pre-made, right? The only problem with the ingredients though is my sandwich might just be sourdough, wheat, and white bread and nothing else, which wouldn't be the best sandwich. But that's the idea, is it's whether it's already pre-grouped together or everything's loose like that and you could get every possible combination. Somebody else might get a sandwich that's just cheese and peanut butter, which would not be good either, but hey, no bread, just cheese and peanut butter. That was a pretty good analogy. We had to make sure we recognized that they were all different. Other comments or questions about that one? This is the hardest thing to really own. Always go back to, I like the way we're discussing this, 2 criteria for simple random, every individual and every group, and it can be compared to pulling names out of a bowl. Okay, before we go on to the rest of it, I'm going to go ahead and take our break now. I want to figure out what the computer issues were with a few of you. A couple of you had add code issues. So we'll take a 10-minute break from here. We'll come back and finish talking about 1.3. I want to show you a little bit about how to access your homework. We showed you last time, and now most of you have gotten that far. And how to get to the textbook if you're trying to read the textbook online. I've had a couple questions about that. This paper tells you a lot of things. On the first side it says navigating within my stat lab. This side tells you how to get into my stat lab. You actually don't have to go into the course at all if all you want to do is homework. You can just click on the links from Canvas. But if you want to read the textbook, if you want to do some extra quizzes that the publisher has made up, if you want to do some extra practice, there's all kinds of things here that you can find. I'm going to show you how to get in there. Apparently not. So once you sign into Canvas, I think it'll let me do it with mine. We'll find out. I changed my password yesterday and my brain can't handle it. Okay, where are we? This is awesome. So once you log into Canvas, it looks something like this. Does that look vaguely familiar? Yeah. So you could just start clicking on these assignments here to do your homework. Assignment 1 coming up. My favorite is to go over here to syllabus. Because when I click on syllabus, it just makes it look prettier. There's a calendar, and here's everything that's due on Monday. Here's everything that's due next Wednesday. And so from here, you can just start clicking on a homework assignment. But let's say I'm not ready to do my homework. I want to read the textbook first. Jill said to read the textbook before class. I want to read the textbook. We'll do the homework in a minute. Because we're all overachievers, and we're going to read everything we need to. To access the textbook's a little bit different. It actually says right here at the top of the navigating my math lab, it says to go to My Lab and Mastering. That's over here, right underneath syllabus. Right here. When you click on My Lab and Mastering, it takes you to this page. It has all kinds of different links. You want to come all the way down here to Student Links and select My Stat Lab Course Home. Warning, it just happened to us and it happened to somebody else. Your computer most likely will block pop-ups, so if you don't watch up here to see if the pop-ups were blocked, you have to allow the pop-ups or it won't open this new page here. Once you get to this page, it takes you to what's called the My Stat Lab homepage. It's as if it doesn't care if you have Canvas or anything else. Before Canvas was used at this college, we went straight in this way. I fixed it already. So this is what the homepage looks like for my stat lab. But all these things over here on the left are what I'm referencing on this page here. So the homepage is where I am right now. And it even has what to do next, just like it did on Canvas, so you can click on those. But more importantly, you have the e-text, which is where you're going to read your textbook. If I click on this, it's going to take a while to load, so I'm not going to click on it. But if I click on this, it will open the textbook starting right from page 1. Instead of e-text, though, I prefer chapter contents because it takes you directly to the section that you want. So if I click on chapter contents and chapter 1, and I want to read this section 1.3 for next time, I'm going to click on just the section I want and choose e-text over here. And then it will take me directly to the first page of section 1.3 so I can read that section before class next time. The first time, oh, then you have to have your Flash player updated. And I can't do it because it's not my computer. If you have your Flash player updated, the textbook will load and you can just flip through the pages. Can't show you on this computer, sorry. But the most important thing is that to get to the textbook, you have to click on that My Lab and Mastering link and then the course home to get to that page. If you're not reading the textbook, you're reading it in the math lab, or you bought the physical textbook so you don't need the online textbook, you can do everything right from your Canvas page. I like to start at syllabus because I think it's prettiest. And I would just come in here and click on this first homework assignment, section 1.1. Most of you already done it, I saw that, that was great. It opens this up, it shows you your score. Look, I've got 1 point so far out of 12. I've scored 1 out of 12. And I got it wrong, is what the red X means. So clearly I need to keep working on my homework. So on the back side of this page, it says to complete homework. So once you click on the assignment, you're in here. The first thing I'm going to do is start on question 1. I click on question 1, it takes me to the exact question. This is a horrible computer, so that doesn't have all my help here. But so I read it and I can choose one of these and select the appropriate box and so forth. If I need some help with this question, because I'm confused, my notes aren't very good, maybe I wasn't sleeping in class, not recommended. I can come up here to question help, and I could choose the textbook, which would take me right to the textbook for this section, so I could read it for reference. I can't show you that right now because my Flash player is outdated. I could ask my instructor. Ask my instructor is one of my favorite ones because everybody, well, not this problem, but once we start having numbers in our problems, everyone's problem is actually a little bit different. So yours might say, find the median for this list of numbers, and your list is going to be different than this person's list, so I can't help you referencing that without seeing your problem. So when you click Ask My Instructor, it sends an email directly to me with the exact link to your problem, so I know what your numbers are, I even can see what answer you put in there. So you can email me and say, hey Jill, help me out with this. I tried this and that, and I'm telling me it's wrong. What am I doing wrong here? So you can always email me directly as well. Later on, when there's more computation, in addition to these options here, there will be help me solve this. There's nothing to solve here. And it will actually take you step by step into all the little things you need to get there. So you can have all of that while you're working on the homework. So all of this is listed on all the options that you have here. Help me solve this, clicking the textbook, ask my instructor. But the best thing is I can get this wrong. I have to make sure I get it wrong. And I check my answer, and it tells me I'm wrong. And so I have to read again. And then I'm gonna have to make sure I'm getting it wrong. If I keep getting it wrong, eventually I'm gonna do my final check, and it says, look, these are your answers, but it should have been B. But now I think I understand it finally, so I want to try the problem again. So at the bottom here, oh sorry, now I have to go ahead and answer some more questions. Darn it, it's a 2-part question. Let me see if I get this part right. I have to read it real quick. Let's see. Nope. I didn't read the whole problem. I don't know why it's not entering, but I'm not going to read the whole problem. Let me get it all wrong. Okay. So at this point, I got that part wrong too. Oh, there you go, I didn't look at the whole thing. Should have been D and D, I only answered E. So it tells me what it should have been. And I can go on to the next question, but I just got that last one all wrong. So I can keep doing my homework. Let me go back out of here for a second. Got too many windows open. If I go back to this page, look at it. It'll show you that I got problem 1 wrong still. But I want to redo it because I think I understand it now and I want all the points. The thing I tell my students about homework is that you technically have no excuse for not having a perfect score on every homework, because every problem you can redo until you get it right. So why wouldn't you keep doing it until you get it right? Not only are you going to get the points, because most of us are about the points, but you will also learn what you need to learn so that when the test comes, you know how to do it. And so I tell people, if you have any red X's, if it was half right and half wrong, I'd have a green and a red, and she'll be part right and part wrong. But you can always click again right here. I don't. Where did it go? Oh, it went back to this page. So I can go down here and now I can click try again. So I got this part. It tells me what the answers should have been, what my answers were. So now I can click try again. It's really the same information again. The things are out of order. When it's multiple choice, it's almost too easy because you just have to remember the right answer. But later on, you're going to have to punch in some numbers, and you can't just guess. There's an infinite number of numbers there. But so this page tells you how to get to the textbook, which is important for a lot of you, and then all the options you have in your homework. I highly recommend you redo every problem in your homework until they're right. I can't force you to, but wouldn't it be nice to say, hey, I have 100% on homework? And the tests are not as easy as the homework, and you can't keep redoing them. So it's better to cushion your grade with the homework score than not. And you'll be more ready for the test, I'm telling you, if you keep working through that. So questions on this handout? Or how to access that online? Everyone who was having issues, we think we resolved them, right? I think we're good for now? All right, let's talk a little bit more about statistics when we get out of here. Clearly I have to finish my homework. If you noticed, there are 3 homework assignments due on Monday. The one we did last time, section 1.1. So section 1.2 that we just finished talking about, the categorical versus the quantitative. And then the 1.3 that we're working on right now. So everything that we'll have talked about up through the end of today is all due on Monday. Okay, 3 assignments. All right. What am I doing with my notes? So we left off about simple random sample versus random sample. Anybody have a follow-up question on those? You asked me again in the lab, that's okay. All right, so then there's sampling methods, how you get your sample. So say I wanted to get my 4 out of this group again. I want to sample a size 4. There's a lot of different ways we could do that. Some are more effective than others. The best case scenario is to have a simple random sample. Best case, but simple random samples are hard. For this group, it wouldn't be so hard. There's only 40-ish of you, so I could put your names in that really easy and pull them out. But if I'm looking at the entire population of the U.S., getting a simple random sample out of all those people would be pretty challenging. Right? I mean, how am I going to do that? Take my whole population, but everybody, I don't know, some people don't have, what if I use social security numbers and a computer? Maybe that would work. Some people don't have them, some people have 2. Some people are, it'd be too time consuming. So there's a lot of different techniques we use to get decent samples. One of them is called systematic. This is the easiest one, I think, to understand. You pick some starting point and you pick every kth. And the k just could be any number. Like I'm going to pick every other person or every third person. So maybe I'm going to roll this invisible die I have here and it comes up to be a 5. So I'm just going to go along and count every 5th person's going to be in my sample. 1, 2, 3, 4. Okay, she's in my sample. 1, 2, 3, 4. Okay, now I've got her. I'll just keep counting, and every time I get to 5, that person will be in my sample. Is that random? Does everyone have the same chance of being in my sample? If I do that? If I pick every 5th We didn't know it was gonna be a 5 in advance. I see some yeses and some nos, and some I have no clue, Joe, what you're asking. Are you saying yes, or you're with that you have no clue? You think it
I
is?
think you have a good chance, like everyone has the same chance because you didn't select the rule beforehand, you didn't organize students in a way that would benefit your sample.
Yeah, I didn't really organize you in any way, and before I roll my die and happened to get a 5, you didn't know what number I was gonna roll. So I could just as easily as I'm counting through here land on this student as I could on her. I mean, you don't know, so everyone has the same chance. Once I pick the number, obviously that changes, because it depends on where you're sitting. But it is random, actually. Systematic is random. Because once you pick the number where you're sitting, you're just as likely to be sitting on the 5th person as you aren't. What about simple random sample, though? Would that be a simple random sample? I quite no, is what I hear over here. Why not? Who was it that said no? You were right. Was that you, Michaela? No? Look at it, that wasn't me.
Well, because you can't get every group and every group is possible.
Because you can't get every possible group. If I'm picking every 5th person, and she happens to be number 5, Christiana can't be in her group because she's not going to be number 5 because she happens to be sitting right behind her. There's no way to get a group, say, of everybody in this row. So every possible group. Yes, every person could end up being the 5th, but not every group could be because of you're already all sitting down. So but by going systematically, you can't make it simple random sample. Convenience sampling. Selecting data that's easy to obtain. So I need a group of 4. I've just decided that I'm taking these 4 people right up in front because they're the closest to me and I can hand the papers quicker. That's a convenience sample. I picked these 4. It was easy. It was whatever was convenient. When people send out surveys, not only is it a self-selected sample like we talked about last time, it's also convenient. I'll just take whatever information I get. Most of the time, people use convenience samples, but statistically, they really aren't very accurate because you're just using what's convenient. If I was trying to survey LMC students in general, the whole population of LMC students, I might choose you guys as my sample because it's convenient for me. You're here in this room and I'm talking to you. But do you represent all LMC students? No. I mean, you guys are actually very similar in so many ways. You take classes in Brentwood, not all LMC students do. You are eligible to be in statistics, not LMC students are. You are able to take classes in the mornings, not everybody is. So there's all these things that you have in common. You're all enrolled in my class, not everybody is. So there's all these things you have in common that the general population doesn't. So that's just a convenience sample. I could find out, the average GPA in this room, but it shouldn't necessarily represent the whole population because you are all a different group. You don't randomly select or represent everyone. So convenience sampling is what happens most often, but is the least telling in terms of reality. The goal is to always have a simple random sample or something close to it, but it's very hard to do. Stratified. Stratified sampling is when you divide into groups that share some characteristic. Doesn't really matter what the characteristic is. I could divide you into groups by rows like I did earlier. I could divide you into groups by last name. Just take the first 4 people on my roster, the next 4 people on my roster. I could put you into groups by height, or by where you live, anything you want. And then, so you divide into smaller groups, and then a sample is drawn from each group. So let me talk about this because the next one's going to sound similar again. So for the sake of ease, I'm going to say I divided you into groups again by rows. And I'm going to select one person from each row to be in my sample. So I'm going to come over here and I'm going to flip a coin or roll some dice and pick one of these ladies over here. I'm going to pick one from this row, one from this row, and so forth. That's called stratified. I have some groups of whatever the groups might be, and I picked some or one or more from each. That's stratified. Now, is that random? Especially if my groups are exactly the way you're sitting today. So these are how the groups are. I've got this first row has 3 people, 4 people, 5 people. And I'm going to pick one out of each row. Does every person here have the same chance of being selected? If I'm choosing one from each row.
Yeah? 'cause
Yes.
It's not assigned seating, so.
It's not assigned seating. Okay, so let's talk about it. I'm gonna come over here to your row. I'm gonna pick one of you. What's the chances that I get her?
1 to 3.
1 out of 3 is her chance of being in my group. What about her?
1 out of 4.
Uh-oh, she's got a 1 out of 4 chance of being selected. Do they have the same chance of being selected? That's not random then. Remember, every individual has to have the same
You get
chance?
2 groups, right?
Say that
You
again?
get 2 groups.
Right, I have 2 different groups that aren't the same size, so you don't have the same chance.
So there's 2 criteria, whatever.
Well, I don't know if it's 2 criteria, it's that the groups are not the same size, which affects the chances of being selected. If we went back to my earlier example where I said pretend there were 4 in each, if there really were 4 in each row, everyone would have the same chance of being selected. Everyone would have a 1 out of 4 chance of being selected. So it's really just, does everyone have the same chance is more the issue here when I ask if it's random. But because my rows are not evenly, you guys aren't evenly spread out, these ladies over here, they're in luck. They have a 1 in 2 chance of being selected. They're much likely to be in my group than anybody else. Well, you guys too, because Nick could be in your group. So that's what stratified is. You divide it into groups and take some from each group. Yes, ma'am.
And the groups don't have to be like even, because it's saying like, you could do it by age, gender, income, so it's gonna leave lots of like.
Oh, right. They do this all the time, especially when they're taking like polling results or by counties. There's some counties in the state of California that are much bigger than other, and they take some people from each county. It's not really representative because, you know, Contra Costa County has so many more people than, you know, Humboldt County. We have hardly any people up there. So the groups don't have to be the same size and nothing. So they're taking some from each, which automatically, unless the group happen to be the same size, it won't be random. It happens all the time with the states of the United States. If you take some people from each state, you guys do not have the same chance of being selected as people from Alaska. There's a lot less people in Alaska than in California. So the chances of you being chosen out of California is much different than somebody in Alaska being chosen because there's so fewer people out there. But they still would be doing a stratified selection by taking some out of each group if they divided us by states. Now, read cluster, and we'll talk about the similarities and differences compared to stratified. Who wants to tell me the difference? Yes? Go ahead.
Well, there's divided into groups, stratified, you're divided into groups and one person's chosen from that group. Whereas a cluster, you're put into clusters and the cluster's chosen rather than the individuals in the cluster, right?
So let's say it again. So they both are groups. It's confusing because one says groups, the other one says sections or clusters. It's groups. There's groups in the first one, a section or a cluster is another group. So they both divide people into groups. Stratified that we just talked about takes 1 or more. We could take 2 out of every group if we wanted. We take some from each group. So if I wanted to take 2 out of here, 2 out of here, 2 out of here, I could do that. That would be stratified. But cluster divides you into groups. Let's keep you in the same groups I have you in. And then randomly picks the entire group. Like I might roll my dice again and say I want everybody in this row, everybody in that row, and everybody in that row. You take the entire group. That's what makes it cluster. So you're taking this large chunk, but you guys are tied together forever. If I pick him, that means I got all of you because you're all in that one group. So stratified is some from each group, and cluster is some entire groups, but not all of them. Lots of vocabulary the first week. We'll start doing some math eventually, and then you might wish for the reading vocabulary again, I don't know. By the way, I'm never gonna quiz you on definitions, but I'm going to ask you to recognize, is this cluster or is this stratified? Is this discrete or is it continuous, that kind of thing. Questions on the differences between those two? And then finally, multi-stage is some combination of those ones up above that we just talked about. So maybe you're going to divide into cluster and you're going to take some from, or excuse me, you're going to do stratified and you divide into groups and you're going to take some from each, but the way you're going to take some from each is systematically. So now that I put you in the groups, I'm going to take every other person, right? That would be a combination of systematic and stratified. That would make it multi-stage. Lots of different ways. You think statistics is all about numbers, but a lot of it is how do you get your group, your sample to begin with, to not have any bias, to make sure that you represent the population so that now you can actually answer all your questions. Questions from here? Okay, so here's where we are. We're done early. Mark this on your calendar. It very rarely happens. But we're done early today. I'll hang around for the next half hour if you want to start. For those of you who have my handout, oops, I have a question. I do not collect the lab. I just give you the quizzes on the lab. So if you want to make sure it's right, talk to me in my office hour or my lab hour. For right now, if you want to hang around and start working on the 1-2 and 1-3 lab, this is what your quiz will be on Monday. I'll stay here. I'll be going to the lab after that at 11 if you want to join me in the lab. If you have any questions about the online homework, we can do that as well. If not, I'll see you on Monday.